And then another tool that will become useful is this ChemSketch. Okay, so like when you want to write an equation, like a chemical equation with a structure. Okay, so because if you have to draw certain molecule, chemical molecule, then you can't just type it CH2, CH3, and like sometimes you might get lucky just to get away with that, but for huge structures you can't just type it out, right? So there should be a tool. So we have this free tool called ChemSketch. Again, you might have used this tool before. ChemSketch. So you just have to, yeah. So this one, structure drawing software for academic and personal use. ACD Labs, the first search result. So you can go to that. Okay, it's coming. So this is totally free for academic and personal use. So you can just download. I mean, they have a commercial version, but we don't need that. The freeware version is like, it has almost everything. So you just have to click on download and then just a bunch of clicks and then you'll be fine. Just like you install any other software, you just have to say next, next, and next, and it will get installed. So I can just click on that. Yeah, and then like there is a, okay, you must enter a valid email address. Okay, it's straightforward, right? I mean, just put your email address and country and things like that, and then you will get probably get an email. Then you can just download. Okay. Yeah, that's it. Just put your things here. We don't have to provide disabled, and then just click this. And then wait. Okay, you must complete the form here before you can. Okay, then what happens is you get a code. You get a code in your email. Just put that code here and then click download. Then it will start download. Okay. Then to tells you the installation instructions and everything. You will have an icon. I think in my case, I did not install an icon here, but you can just start typing ChemSketch and then it will come up here. So you can just click on that. Okay. Then you can just start typing your things. So we will straight away like see what we can do with, let's see. Something like this, a reaction like this. Something like this, okay? Okay. So this is the software. So you have, it looks like it's quite complicated, but it's not. when you get when you practice with this more and more, you will get the hang of it very easily. So you have the periodic table here, right here, the periodic table. You click on that, you'll get a periodic table like this. So the colors have been used to indicate the different blocks. Now this green color for the 1s block, I mean the light green color. Slightly darker green color is for the P block. Then you have this blue color for the S block. Now this is especially for 1s. So you have F block in this color, likewise. So if you click on a particular atom, you will get some information about that, the mass and the oxidation states, some idea about the electron configuration, and some general information about, for example, titanium, who discovered that, which country, and why it is called titanium, and atomic radius, electronegativity, ionization potential, density, melting point, boiling point. All that information will be available there. Okay. So this information is, and even the isotope information. Okay. What are the available isotopes and what are the percentages, percentage abundances, right? So all that information is there. So there is just for the knowledge, and you can even color this. There are different color schemes, like the coloration can be changed so that it can be metals and non-metals, and radioactive and non-radioactive elements. Okay, likewise, and how they occur in the ground state, as whether it occurs as a liquid, gas, or a solid. So depending on that, how they can be categorized. Okay, so then we can get into business now. So we are going to look at this reaction here. So ethyl benzoate. So you have this, so there are two main modes, structure mode and the draw mode. Okay. So depending on in which mode you are, your tools are different. So this is the structure mode. The structure mode, on your right hand side, you have things like this benzene ring. See, the benzene ring is already there. So you can just click on that and then place it wherever you want. Okay. If you click here, you can see the benzene ring there. So if you click again, there will be another benzene ring, and you don't want that many benzene rings. So once you have your benzene ring, what you can do is click on escape button. Click on the escape button. Then it will not input any more benzene rings. Okay. So after that, you have an extra benzene ring here. So you can remove that by selecting it. So for selecting, you have the select move button here. So you can click on that, select move, and then you select this thing. And if you press delete, it will be deleted. Okay. So the reaction we want to write is this one. So you have COO, CH2, CH3. So whenever we click on one of these elements, like we can have any element we want. Like these are the most frequently used ones that are given here, but we can add anything from the periodic table to this left-hand side, okay? So right now, what we want is COO, CH2, CH3. So we basically want carbon. So if you just click on carbon and click here, it will have the hydride, okay? So that is CH4. So you want COO. So you have 2 oxygens. So you click here, another oxygen here. So, but you will initially get the hydrides. That means just the water, and then here methane likewise. So after that, you have CH2, CH3. So CH2, CH3, another 2. So don't do that. So you can initially put them like that. Then you can start bonding them together. So to do that, you can click on this draw normal, and then you connect them together like here. So that becomes CH3, and then you do it like that. So you have COH, and then you connect this one with this, okay, O, and then here with this. So you basically have CH2, CH3 here, and then here you have to have a double bond. So you click here once, and it becomes a double bond. Okay. Now this doesn't look very good, like in terms of the shape of the molecule. It doesn't look right. So you can clean this structure. To clean the structure, you can select the structure. You click here, select move, and then you select the structure. And then here you have the clean structure. So when you clean that, it gets the correct shape. Okay, gets the correct shape. So you have COO, CH2, CH3. Okay, and then you have the benzene ring and the COOH. You call it the benzoic acid, right? The benzoic acid. So again, we draw another benzene ring here, somewhere here. Then you press escape so that it will not insert any more benzenes. So just like before, you can actually you can even copy this thing without drawing the whole thing. You can even copy this thing, but just for the sake of drawing, I'm gonna do it so that you'll get more experience with that. So we need another CH4 here, C, and then oxygen, and then another oxygen here, right? COOH. Okay, so then we start combining them together. Okay. So here there should be a double bond. So we click on this bond one more time. So it becomes a double bond. So we have COOH. This structure also we can select it, and then we can clean it so that it looks good. Okay. And we have CH3, CH2, OH. So that one. So if we click on this one more time, if we click on this carbon one more time, it will attach another CH3 to one of the hydrogens. Okay. Now we have CH3, CH3. Now if we click on this carbon again, we have CH3, CH2, CH3. So we can keep on clicking like that if we want to add more and more CH3 groups, but we don't want that many. So we can undo this. So we want CH3, CH2, OH. So we want OH here. So we can click on O and then click on this C. It becomes OH. Again, we select this and clean the structure. Actually, there's not much change. Okay. So we have it like this. So if you don't like, if you want it to be exactly like this, you can rotate it. So the way you rotate it, you have this option here, which is to rotate. You can rotate it. So you click on that. You bring it here. So at one point, it becomes like a curved arrow. See, becomes a curved arrow. So then you rotate it. Actually, you have to, so whatever the way you like. So CH3, CH2, OH. Okay. Okay. So up to this point, are you guys okay with what I just did, or do you have any questions? Yeah, I mean, if you have the exact reaction, so there is a question like, rather than drawing the reactions separately, can't we get a photo of the reaction from the internet and put it in the paper? So how do we know like the exact reaction we are talking about is there? Like right now, it might be the case, but in the future, some of you, even in the industry, you will have to draw some customized reactions that will not be there in any of the papers. And even if you cut it and paste it, like copy and paste it from another place, from the internet, the quality will not be that good, because when you copy and paste something, the quality decreases. So the quality will not be that great. Okay, so it's always good to know how to draw the reactions like step by step. In case, I mean, most of the time the reaction is not there. You have to draw it. As you go further and further in your field, most probably the reaction has not been written by anyone else. So you have to write it. I mean, in some occasions, yes, the reaction is there, but still, I mean, then there are, you know, there can be copyright issues, and the quality of the figure might not be that great. So, and then we can, so we have drawn like this one, and this one. Then we have to put the conditions. So it says sodium hydroxide, ethylene glycol, and heat, and then HCl. So we have the arrow here, this one, reaction arrow. So we can draw that reaction arrow. Okay. And when you have the reaction arrow, you can write the conditions. So here it says, sorry, not this one. Here it says reaction arrow labeling. So you click on that and click on that one. So now you can write the conditions above and below the reaction arrow. So you have NaOH, ethylene glycol. So you can write it here, NaOH. You can increase the font size. NaOH, ethylene glycol, and then heat. There is heat here. Okay, and then below you have HCl. Here also you can increase the font size. So it will appear like this. Okay. So that is how you write it. And then once you are done with that, you can export this. I mean, this arrow might be a little bit, so you can change the arrow like this. Actually, you can rotate it a little bit, so you can rotate it. It looks fairly straight to me, but it's just, yeah, it's okay. I mean, you have to wait until it becomes those two arrows, and then you can rotate it a little bit. Okay. So once you're done with that, you can select this thing. And then you can export. File, export. And when you export it, there are options about the quality. You know, so this is just a MOL file, but you can export it as a JPEG image. So when you have the JPEG image, you can decide on the image resolution. So 300 is usually a high resolution image. You can increase the quality, compression quality to 100. You can give it any name you want. I mean, first we give the name. So we can say something like reaction 2. Then options are okay, and then we save. If you go to that place and have, you can see it like this. So it's a high resolution image that you can add to your research. Okay. But when you copy it and paste it somewhere, from somewhere else, usually the quality is not that high. If somebody enlarges or zoom in, then it might get pixelated a little bit. Okay. But this one, you can see zoom in as much as you want. it will still have very high quality. Okay. And even then, it only has a size of 55.8 kilobytes. So it's a very small file. So you don't have to worry about it. And then we can look at some other things we can do. So this is like the primary need to write reactions like this. But it can do a lot more than that. Like for example, now just imagine now this is a, like I will just remove this. Okay, I will remove this for the time being. So if this had been an equilibrium reaction, so then you'll have to change the arrow, right? If it is an equilibrium reaction, you have to change the arrow. So you click on that and right click object properties. So object properties, you go to this arrow. Arrow, you know, if it is a reversible reaction, there should be two arrows in opposite direction. So we can choose this one for the forward reaction and then click apply. Then we can copy this and then press Ctrl V and then put it here again, but it will appear in the same direction. But now we can change the arrowhead of that one to the other direction. So first we have to go. So this is the start and the end. So start is like this, end should be like this. Okay, so this is the start and this is the end. The shape of the beginning of the line and shape of the end of the line. So for this backward arrow, the beginning of the line should be like this and end should be like this. That is what you have to specify. So if this is a reversible reaction, that is how you change the arrows. Okay. Similarly, after you do that, you can just go to file, export, and export a high resolution JPEG image of this. Another thing you can do is like you can even name the structures. If you don't know the name, if it is quite a complex compound, we can just try and see. We can try it with a simple compound. Okay. So for example, we can start drawing something like this. CH3. You can. So if you click on this carbon and drag it like this, see it will be adding a CH3. So one of the hydrogens will be replaced to the CH3. If you click on this carbon again and drag it like this, again one of the, now this one is CH2 in the middle. So one of the hydrogens will be replaced by a CH. So again you can click on that likewise. So but you know it is not the correct shape. So what you can do is like you can select this structure, right click object properties. Okay. So you can see right now only the terminal carbons are showing. So we can we can show all the carbons. All the carbons we can apply. It will show all the carbons. And if you want to get the, I want to tell you one more thing, like we can So if you, while you are dragging this thing, you can press the shift. So you can, while you are dragging, you press shift in your keyboard. Okay. So now it will increase the length of the line step by step. Now this is one step here. If you drag it further, the second step. Did you see that? One step, second step. Then you release it. This will be the length. Again, you click on this, press shift, 1, 2. Now your this lengths of the intermediate lines will be the same length. So you have drag it once, twice, release it. Okay. So then you select the structure, right click, properties, all, apply. So you have something like this. Okay. If you want to add another one, right, like this. Okay. Or else you can just. Now we can replace some of these. Like let's say we can replace one of these hydrogens with an OH group. So we do it like this. Press shift. We first click on oxygen. Shift. And then we click and drag. Okay. So one of the hydrogens is replaced by the OH. So we can replace one of these hydrogens with a bromine. So we click on bromine. Bring it here. Press shift. Yeah, bromine. Let's say okay, let's add another CH3 here. So we can add another like a double bond, like a carboxylic acid group here. So we can add, we have to add the C double bond O. So what do we do here? So we press shift. Okay, now we have an OH. So this is a single bond. So if we click on this one more time, it will become a double bond. But this is a CH3, so it has to be removed and replaced with a hydrogen in order for this to become a carboxylic acid. So we click on hydrogen and then we click on this carbon. So it becomes a hydrogen. Sorry, actually this has to be an OH group because now we have to have an OH. Because we want it to be a carboxylic acid, right? So COOH. Now, if you want a name for this compound, so we click on this, it says select, then we select this, and then we can click on this one right here, generate name for structure. Generate name for structure. Then it will generate the name for the structure. Okay. That is another thing you can do. And then you can do some further things with this. Let's say you want to draw something like this. Something like this. So how are you going to do that? So we will keep this on the side. Okay. So if you want to draw something like this. So first you need a CH4. First you need a CH4 to start drawing this thing. You need a CH4. So we click on carbon and then we click somewhere here. So we now have a CH4. And then we need to have these hydrogens replaced by CH3 groups. Hydrogens replaced by CH3 groups. So what can we do? We click, now we have already clicked on carbon. We click somewhere here and then press shift, then drag, we drag once, drag twice. Now one of the hydrogens is replaced by CH3. Again, you do it again, once, twice. Okay, so now we have another hydrogen replaced with a CH3. Then you do it one more time. Okay, have it like this. Okay, now if you want to visualize all the carbons here, all the carbons, you can select this and then apply, click on all and apply. Then you can see this carbon also. Now you can see in this one, this carbon has a negative charge. But here you have a hydrogen, therefore you don't have a negative charge. So we can come right here, this plus, that is for adding a plus charge, but we want a minus charge, so we first click on that. Then we get, in the right hand side, we get a couple of options. We click on this negative charge. And then we come here and click on this carbon. Now that hydrogen is replaced by a negative charge. Okay. Hydrogen is released because we can't have a hydrogen and a negative charge, then that the structure is wrong. So now the hydrogen is replaced with a negative charge. Then the other thing we can do is, now this one is going back, like it is, this is coming out of the plane, this is going into the plane. And this one is on the plane. On the plane, coming out of the plane and going into the plane. You know, I think from your advanced level knowledge, this means going into the plane, this means coming out of the plane. This is in the same plane as the plane of this computer. Okay. So we have that option here. You can see here. So we click on that. You click here. You can change it like that. Then you click on this one to go into the plane like that. Okay. And then you have these other orbitals. So these orbitals can be taken from, we have this one, this open template window. So we have a couple of templates already available. Templates. We have so many template molecules, like all the amino acids are available. So we can just select one of these amino acids and drag and drop it, like we can just drop it here. We don't have to draw any of the amino acids. It's already there. All the amino acids, D amino acids, L amino acids, radicals, everything is there. Anions, okay, nitrates, nitrites, cyanides. You don't have to draw any of them. Aromatics, okay. Any of these, all these rings, like they are available by default. You can just select them and put them there. Okay. So there's like a whole library of molecules that are available to you. Okay. So one of them is orbitals. And you can choose this one here. This one here. Click on that. Then it is asking like, where should we drop it? So we can drop it somewhere here. And then we don't want another one. So we press escape. Now we have to rotate this. To rotate, we click on this one, select move rotate. And then we have to rotate this. So we, like 90 degrees, we have to rotate. So that looks good enough. So then we can move it here. Okay. Can move it there. Then we have to have the lone pair. The lone pair electrons, like in this case. So we have, again, from the templates, we have lone pairs. Lewis structures. This one, this has lone pairs. See, you can just click on that and just drop it here. Okay. You want to drag it a little bit. Okay. Likewise. So you have that structure. So that is how you draw that kind of a structure. You can, like, once you get the hang of it, it will be very easy for you to draw it. Okay. Are you guys okay with that? Do you find it too difficult, or are you guys okay with that? I mean, this might be, you never know, right? It might become useful to you in the future. So this is scientific communication. So we have a reaction in your mind. How do you communicate with your scientists, other scientists, peer scientists? So you should have a bunch of tools to scientifically communicate with the rest of the scientific community. So those are the tools that you are going to learn under this course. So when you have these tools, knowledge of these tools, you can communicate with the rest of the scientific community. So that is scientific communication. So in order to successfully communicate as a scientist, you should know this, should have these skills. Okay. So that is done. So let's say now another important thing you should know is how to draw a reaction mechanism. So it is quite unlikely, like if you find a mechanism, if you are going for a PhD or a master's degree, you might have to explain a new mechanism for your peers in your research paper. Then you, most probably that mechanism will not be available in other scientific literature because it's a new mechanism or a modification to a current mechanism. Then you have to come up with your own diagram. So how do you draw a mechanism? Okay. So I'm going to take an example. So I'm going to take this kind of an example. Okay. So how do we draw this mechanism? So we have a ammonia molecule. Then we have a water molecule, ammonium, and then hydroxide. I mean, if you know the basics of how to draw these arrows and everything, then you can write any complex mechanism once you get to know how to write these things. You already know half of it. You just have to know about these arrows now. And this square bracket. So ammonia. How do you write ammonia like this? So if you just click on nitrogen, now you are in the draw mode. You can go to structure mode. If you click on nitrogen and click here, okay, if you draw nitrogen and click here, you will get ammonia like this. But you don't want ammonia like that. You want it like this. Okay. So what you can do is, just like before, you can click and drag on these. At the same time, you can press shift while you are clicking and dragging. Press shift on the keyboard so that your bond lengths will be the same. Bond lengths will be the same. So 1, 2. That's it. Then 1, 2. 1, 2. Okay. Now you don't want NH2 groups here, you want hydrogens. So you can click on hydrogen, then press click on this nitrogen. Now you have ammonia like that. And you want this this bond to come out of the plane, this bond to go into the plane, and this is in the same plane. So you click on this and here, so it is coming out of the plane. This one is going into the plane. It's the same plane. And then the lone pair. Okay, the lone pair. Just like before, I mean, there is another place from where you can get a lone pair. This is one place. There is another one called reaction symbols. Now this one is a little big. It's like it's a little bigger. So if you want to go for a slightly smaller one, you can go to this reaction symbols. Reaction symbols, and you have a slightly smaller version here. So click on that and click right here. Okay. And then you press escape because you don't want another pair. Okay. Now you have the ammonia. So this part is okay. Then you have to have water with 2 lone pairs. So just like before, have you this time you click on oxygen, right? You click on oxygen. First it comes like this, and now you want to unravel it. Okay. So what do? You can just use any of these to drag it out. Actually, I had accidentally clicked on this one, so it's not what I wanted. Okay, so I can just undo that. So I wanted to click here and then shift. Okay, now we have, and then you add the lone pairs. Have one here, another one here, and you have to rotate them. Now this one is for rotation. Bring them a little closer, and then this one, rotate it and bring them a little closer. Okay, so that's it. That's water. And then you have this one here. So you don't have to draw this whole thing again. I'm going to click this one and copy it, and then press Ctrl V. So you place it here. And then I'm going to add another hydrogen here. So what do? You press Shift, drag it like that. Now it automatically added a plus, because the ChemSketch knows that if there are 4 bonds to nitrogen, there will be a plus charge, and you don't need that. I should have removed that lone pair. Now I can't remove it. So I'm just going to remove this lone pair now. Remove that and then add the hydrogen. Okay. Okay, so that's it. And then you want to put a square bracket around this. So the square bracket, you have a square bracket here, you see, brackets. So you bring the square bracket and draw it around this. And then you have OH minus. OH minus. So first you write H2O. Then you can put a hydrogen here. Okay, and then you put a negative sign here on this oxygen. So this hydrogen will be replaced. Now you want to put these lone pairs. You can just get them from this guy here or from this guy. And Control V. So you place 2 here. And another one. Okay. And then another one. That's it. And then you have to have the arrows. The arrows start from this lone pair attacking this hydrogen. Okay, so you have these curves here, arc. So you can choose any one of these. So you first click on the arc, and then you click on, what do you click on? The arrow. Because we don't want just an arc, we want an arrow at the end of the arc. So we first click on the arc, then the arrow. And then we start from this point. Actually, we started too high. So we will have to do it again. Oh, it didn't work. Maybe you want to go to the other one, this one here. Like that. We can bring this a little down. I can like move it a little bit. Move it and rotate it. It's not giving you a very easy time. Yeah. Likewise. Okay. Like that. And then these electrons have to come here. So you can use something like this and the arrow here. if you think it's like touching it too much, like this. Okay, like that. So you get the idea. You can adjust it, like fine tune it a little bit if you want it. Okay, that's what you want to do. Should have been better if this one came a little bit. Okay. Okay. And then, yeah, that's basically it. So you can have the plus sign here. The plus sign, there is a plus sign here. You can add that plus between this and this. And then you can add the reaction arrow here. And then another plus sign here. So that's how you draw the mechanism. Okay. So want to bring this to the same level. So that's it. That's what you do. Okay. Like, I mean, here for any of these structures, you can do a small optimization as well. I mean, you can just select this. If you want to see the real structure, you can just do a small optimization. Here it is available. Here it says, I think this one, 3D optimization. See, it will optimize the structure, like how it will look in 3D. Okay. So just click on that, do a 3D optimization. Then you can like click on this thing. See how it looks in 3D. Okay. So that is one thing you can do. And also you can visualize this one in 3D viewer as well. There is a 3D view option. Somewhere here. Yeah, 3D viewer right here. Okay. So I can look at how it looks like in 3D. So you can see how it looks like in 3D. Okay. You can just rotate it and see how it looks like in 3D. And you can even save one of these as a JPEG or PNG, any image, you can save it as an image. Okay.